Right, this is the famous double bucket problem, right? So these are both 3.2 kilograms, 3.2 kilograms, right? And then this is notice it's massless cord, right? This, of course, avoids the awkwardness of the tension in here being in that cord being not the same number, right? It would be less at the bottom, a bit more at the top because of the weight of the cord, right? Okay, so let's see, 3.2 times 9.81. These each weigh 31.392 newtons, right? That is, I got that by going 3.2 times 9.81, right? So if the buckets are at rest, or if they're moving at a constant speed in any direction, okay, by the way, the tension in each cord, it seems like this cord has one bucket hanging on it, so that guy is going to be 31.392 newtons, and then the top one has two buckets hanging on it, right? So that's going to be twice that, right? So times 2, 62.784. Right, so let's see, there's our 31 newtons, our 63 newtons, right? Okay. Then it says if the two buckets are pulled upward by an acceleration of 1.60 meters per second squared by the upper cord, calculate the tension in each cord. That's going to take a little more doing, right? So I'm going to show you two ways to do this. The first way will be the party line, and then I'm going to show you a quick and dirty way to do this. So let's erase that, right? Let's look at this bucket here. We're going to find that force in that cable, then we'll find the tension in this cable here. Okay, so for this guy, we've got the force of gravity, which is 31.392. And we've got the tension in the cable, right? That's T. So I'm representing the bucket with that little dot right there. Okay, so for the lower bucket, okay, the tension, I can just go tension minus 31.392, and now they're accelerating up at 1.6, right? That equals 3.2 times 1.6. So now I can figure out the tension. It's going to be 31.392 plus 3.2 times 1.6. That's 36.512. Right, so I would argue with that. I think that's 37. I just got these answers out of the solution guide, right? So that's this tension. This one's 36.512. Okay, so now let's look at the upper bucket, right? Now we know that for the upper bucket there's a force down the upper bucket, right? I'm going to draw the dot over here, right? There's a force down of the tension, which is 36.512. There's also, how do we draw that? I'll draw it next to it. The force of gravity, which is 31.392. And then there's also the tension, which is upward, right? Our T. Okay, so for the upper bucket, we've got three forces. We've got the tension upward, we've got the force of gravity downward, and we've got the tension of the lower bucket, right? So there's actually 1, 2, and then gravity is the third force, right? So our formula looks like T minus 31.392 minus 36.512 equals 3.2 times 1.6. I can almost fit it in there. Yes. Okay. So that guy plus 31.392 plus 3.2 times 1.6. 73.024 newtons. Right? That's the upper tension there, right? Okay, so that is all well and good. This is how you are supposed to do it, right? Set up an equation for the lower bucket, then do the upper bucket. Can you do it the other way around? I don't know. That would be an exercise for the listener, right? Let me show you the pirate way to do this. The fact that you're accelerating upward, right? You could either be accelerating upward or you could be in a place where gravity is 9.81 plus 1.6. This works for all vertical acceleration problems, right? So our new g is 9.81 times 1.6. What did I just do? 9.81 plus 1.6. Okay, 11.41. So it's like you're on a planet where gravity is a little bit stronger. Part of the g-force is, of course, gravity, and part of it is this acceleration. Although Einstein would say that due to one of the postulates of general relativity is that there's no way, I mean, except for obvious ways, right, to figure out if you're in a closed box whether the g-force you feel is from gravity or acceleration. So, bear with me, right? So now we're in a place where Earth is a bit more pulley, right? These are still 3.2 kilograms, that's their mass, but the weight of this one is mg, it's 3.2 times our new g, which is 11.41 times 11.41, 36.512, which is exactly the number we got before, only we just got it a lot faster. Okay? And so, yeah, again, I'd say that's 37, right? Okay, and then the upper bucket would be twice that, right? Okay, because there's two of these things, right? Two 3.2s. It's just going to be twice that weight, so it's going to be 2 times 36.512. So times 2 and 73 point. Okay. There you go. You can solve it two ways now. And if you really watch this awful, boring video all the way to the end just to learn that, pat yourself on the back. Okay, you were destined for greatness.